Hi students, now we are going to derive lens maker's formula and lens equation, which is a very important question in the annual board examination. Okay children, now you can understand the diagram first. So I have considered a biconvex lens, which is a thin lens, a double convex lens, and it is having two curved surfaces, namely ACB, that is the first surface, and ADB, that is the second curved surface. So this is a thin lens placed in air, let us say. Air is a rarer medium. Now O is a point source which emits light. So one incident ray I have taken, namely this ray, okay. So light is incident on the curved surface. First surface is ACB. So when light is incident on the first curved surface ACB, refraction takes place because the light travels from air to glass. Okay, this light which has entered inside the glass should again come back into the air itself on the second side, is it not? Therefore, the second refraction takes place at the second curved surface ADB, and light finally the image is being formed at I. So object is at O and final image is formed at I. One intermediate image is formed, that is at I dash, due to the first surface. Okay. So the first diagram now we have to understand carefully. The first medium outside the lens is air. For the first refraction, the second medium is glass. And for the second refraction, that is taking place at ADB. Okay. The first medium is glass and the second medium is air. So first refraction is from air to glass, second refraction is from glass to air. So it is better always we can split the diagram, okay, in terms of two parts. So I have shown the first curved surface separately. For the first curved surface ACB, okay, air is the first medium and its refractive index is N1. Glass is the second medium and its refractive index is N2. Understand? This is for the first surface. So O is the object and its image is actually formed at I dash. I dash, you can see, okay, I dash is the image formed by the first surface ACB. This I dash acts as a virtual object for the second refraction. Therefore, I have drawn this diagram separately. So ADB is the second curved surface. For the second curved surface, the refraction is taking place from glass to air, and the object is I dash. I dash is the image formed by the first curved surface, but now it acts as the object for the second refraction, and hence it is a virtual object, and its image is formed finally at the position I. I is the final image. So totally these two stages together is given in the first diagram. But better you draw the two separate diagrams so that you can very clearly understand. Now I am going to refer the equation which we have derived in the previous class. What equation we have derived I will write now. Okay. So refractive index N2 of the second medium divided by the image distance V minus N1 by U, and this is equal to N2 minus N1 divided by capital R. You always keep it in mind. The general equation here you write in capitals. Then only you will not confuse yourself. Understand? Don't use a small u and a small v here. Use only capital V and U. Why? Because in these two steps, the distances are different. Say for example, so this distance, okay, this distance I will take OC. So this distance OC is the object distance small u, and the image formed is I dash. So that this distance is taken as V dash. Okay. But this V dash is also the object distance for the second refraction. In the first picture, V dash is the distance, okay, between the image I dash and the pole. Understand? So this distance is the image distance for the first refraction, but it is also equal to the object distance for the second refraction. Very simple to understand. Okay. So V dash is the object distance, and the final image distance. Okay. This distance. Okay. This is V. So instead of writing this small v and u, it is better you write capital V and u in the general equation. So this is the general equation number 1. Now in the examination, how you have to derive this in steps. Okay, for refraction, at the surface ACB, for refraction at the first curved surface ACB, you look at this picture. N2, second medium is N2, first medium is N1. So N2 divided by, which is the image distance here. You can look at the picture, V dash. So N2 by V dash minus N1, okay, N1 divided by, what is the object distance in the first picture? Small u. Now only you are permitted to write small u. Understand that? So N2 by V dash minus N1 by u, and this is equal to N2 minus N1 divided by the radius of curvature. The radius of curvature, you see here, this ACB is pointing towards the right, towards the x-axis. So if you want to measure its radius of curvature, you have to go along the direction of light. So R1 must be positive, is it not? I have written clearly here, R1 is positive. So I am going to substitute here, divided by R1, and this is our equation number 2. A similar equation I am going to write for refraction at which surface? The second surface ADB. Okay, shall we write? So for refraction at ADB, for refraction at ADB, the second curved surface ADB. Now carefully you have to understand and write with me together. For the second surface, okay, the first medium is glass. First medium is glass, second medium is air. Therefore, see here, first medium is N2 and second medium is N1. Understand? So the refractive index of the second medium, I have to write N1 divided by image distance. So in this case, image distance is V. So N1 by small v minus N2 divided by V dash. This is the object distance. This is the only point which will confuse you first. Don't get confused. Understand? So according to our general equation, refractive index of the second medium should be divided by the image distance. So here refractive index of the second medium is N1. Understand? Because first medium is glass, second medium is air. Okay, N1 by V minus N2 by V dash, and this is equal to refractive index of the second medium minus first medium. So this is N1 minus N2 divided by radius of curvature. Now look at the surface ADB. It is curved and it is pointed towards the left. So this curved surface is focusing towards the left. So this radius of curvature we are measuring in a direction opposite to the direction of light, and hence R2 is what? Negative, is it not? So this is minus of R2. Okay. Now N1 also is a number, constant. N2 is also another number. It is a difference. It is a difference between two numbers. What is the difference between 5 and 3? It is 2. So what should be the difference between 3 and 5? It is also 2 only, is it not? So difference always is positive. Therefore, I can also write by the sign conventions, special rules, N2 minus N1 and N1 minus N2 both are one and the same. So I am going to rewrite this equation as what? N1 by V minus n2 by v dash is equal to n2 minus n1 divided by minus r2. This minus you should not change, it is as it is. Understand? So n1 minus n2, the modulus of n1 minus n2 is also equal to what? n2 minus n1. So I have changed the order like that. And I call this as equation 3. This is equation 3. Okay? Now look at the equations 2 and 3. I am going to add. So adding equations 2 and 3. These two equations are added. So I will write the left hand side first. So n2 by v dash, n2 divided by v dash minus n1 by u, minus n1 by u. I have written the left hand side of equation 2 plus left hand side of equation 3. So plus n1 by v. So this is n1 by v minus n2 by v dash. I have added the left hand sides and I am going to add the right hand sides. While adding the right hand sides, you see the common factor is what? n2 minus n1. n2 minus n1. So I will write this is n2 minus n1. Okay, into 1 by r1. Okay, 1 by r1 minus 1 by r2. So this is 1 by r1 minus 1 by r2. Right? So 1 by r1 minus 1 by r2. Okay, now you see here which term get cancelled, n2 by v dash and minus n2 by v dash. Shall I cancel these two? Okay, so this n2 by v dash minus n2 by v dash is getting cancelled. What is the remaining factor in correct order if I will write? So this will become n1 by v minus n1 by u is equal to n2 minus n1 into 1 by r1 minus 1 by r2. So in this order you write. Okay. Now I am going to divide each term by n1. Okay. So dividing by n1, dividing on both sides by refractive index n1. If I divide this by n1 means it will become 1 by v. Is it not? So 1 by v minus this will become what? 1 by u is equal to n2 divided by n1. n2 by n1 minus n1 by n1 is 1. So into 1 by r1 minus 1 by r2. Understand? So we have got this equation. 1 by v minus 1 by u is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. Okay. Now if suppose if the object is placed at infinity, we have studied when object is placed at infinity, the image will be formed at f, at focus, so that the image distance v is equal to what? Focal length. Is it not? I am going to substitute that condition. So 1 by v will become 1 by f. So this is 1 by f is now equal to, or 1 by f minus 1 by infinity. So this 1 by infinity is actually 0 only. We can neglect in the first step itself. So that this is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. So this 1 by infinity is 0. That can be eliminated. So the same. So this is also equal to what? This is also equal to 1 by f. Understand? 1 by f is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. Okay. So now if I will compare these two equations, I will say that this is equation 4. Okay, this is equation 5. Let it be as it is. If you compare the equations 4 and 5, right hand sides are the same. Is it not? So equating the left hand side, 1 by f is equal to 1 by v minus 1 by u. This equation only is called as what? The length equation. Okay, and prior to that, suppose if first medium, okay, first medium is air, and N1 is equal to 1, and if second medium is glass, N2 can be taken as N. Understand? So the above equation can also be written as 1 by F is equal to. So 1 by F is now equal to N2 by N1. N2 by N1 is what? N by 1. I am going to substitute N2 is equal to N for glass and N1 is equal to 1 for air, so that it will become N minus 1. Understand? So that this is what? N minus 1 into 1 by R1 minus 1 by R2. So this equation is 7. I say this is equation 6. Okay. So equation 6. So 1 by F is equal to N minus 1 into 1 by R1 minus 1 by R2. So this equation 6 only is called as lens maker's formula. Suppose if you go to the doctors for an eye checkup, okay, for ophthalmologist, you go for opinion. They suggest some powered glasses to you. Understand? So in terms of diopter, power of the lens is subscribed. The lens maker will manufacture the glass according to the required power. So for that, what are all the informations needed for the lens manufacturer, who is also called as lens maker? He should know the relationship between the focal length of the lens, understand, which is used for the goggles, and refractive index of the glass, what type of glass he uses, and the radii of curvature, of the two curved surfaces. So since this equation 6 is relating the focal length and the radii of curvatures of the lens, this equation 1 by F is equal to N minus 1 into 1 by R1 minus 1 by R2 is only called by the name lens maker's formula. Now comparing the equations 4 and 5, okay, that is comparing equations 4 and 5. The left hand sides are same because right hand sides are one and the same. So I can write 1 by F is equal to 1 by V minus 1 by U. So this is equation 7. This relates the focal length, image distance and object distance, and this only is called as lens equation. Understand? Okay. So this derivation is very easy. You have to practice once or twice by drawing these two stages of diagrams. Split the two refractions into two separate steps and you apply the general equation which we have derived earlier. Have you understood? I hope you must have understood well. Fine.